Welcome to lesson 27. This is about cleaning processes for cleaning validation. In this lesson, we're going to be looking at cleaning processes and cleaning methods. In the cleaning process, we have two types of processes. We've got our manual process, and to validate a manual process, you must validate a procedure, not a process. It has to be clear and an unambiguous SOP because you want to have lots of different people being able to relate to it in the exact same way. Staff need to be well trained or qualified on this SOP or on this cleaning process. And there needs to be very good records of the qualification. The second type is automated processes. These again must be validated. You also need to validate your analytical method, which is giving you your results for your validation. You need to have a well-designed cleaning system. And you need to make careful selection of your cleaning agents, that they're appropriate for the equipment that they're being used for, the materials, and for the analyte that you're trying to remove. There are different requirements for different process stages. Cleaning methods are based typically on the extent of disassembly required for cleaning equipment and also on the methods of contacting the chemical agent with the surface to be cleaned. There are 8 different cleaning methods that you can use. The first one is clean in place. So we're going to talk about each of these in a little bit more detail in a minute. The second one is agitated immersion, static immersion, automated parts washing. You can use ultrasonic cleaning. You can use high pressure spraying. You can have manual cleaning. And you could also use reflux. Your cleaning categories, again, when you break it down, there are 2 main categories. You're talking about whether you clean something out of place, COP, where you disassemble your pieces of equipment or your components that cannot be cleaned in place, and you put them either through a washer or you manually clean them yourself. The second one is clean in place, where you actually clean the piece of equipment or the reactor in the process and it's not being removed. Clean out of place, though, COP. For small pieces or parts of equipment that can be removed, cleaned and reassembled, they would be taken off and would be cleaned separately. This would be particularly in cases where you can't get to it using an automated system. So these would be for equipment pieces like valves or small mobile vessels or spooled parts that are very difficult to clean. The steps involved in COP, first of all, dismantle the parts of the equipment that are to be cleaned. They're pre-washed with tap water to remove the bulk of the residue. Then they're washed in cleaning solution with whatever your specified cleaning agent and concentration is. They're rinsed in tap water and it's rinsed with purified water then to finish. The parts are dried using hot air. One of the key concepts in cleaning validation is to make sure that anything you wash is also dried. Leaving pools of water will cause microbial growth and would be counterproductive. The visual inspection then is done to check whether the equipment is now clean. The parts then can be reassembled. Examples of different parts of equipment that would typically be cleaned out of place. So spooled pieces or connections like you have here. If you've got mobile bioreactors or mobile tanks that can be used, can't be cleaned in place, and valves and things like that would be very difficult to clean in place. Automated parts washing. So this is applicable to your clean out of place again, where you put something into an industrial sized dishwasher. You might even have a full washroom where one side of your room you put in your dirty equipment and the other side you would have your clean equipment coming out. Parts are disassembled and are placed into a mechanical washer to be cleaned, rinsed and dried. Labelling and hold times are really important here, as in everywhere else. You need to label all of your pieces of equipment so they don't get mixed up or put into the wrong process in error. You need to have your dates on them so that you can follow your hold times so you know what's clean and within its hold time. Hold times are the expiration time after which the item would need to be re-cleaned. So you'll have clean hold times, how long you're able to keep a piece of equipment or a component in a clean status for before it needs to be re-cleaned. And you'll also have dirty hold times, how long it can be dirty before it needs to be cleaned. Clean in place, CIP. So CIP applies to all situations where disassembly is not required. In this case, then you're able to clean it in place and the equipment is flooded with cleaning solution. This consists of an automated cleaning system that is designed for aqueous cleaning. The CIP unit, the clean in place unit, so sometimes it's built in, sometimes it's a mobile unit that's come along and it's attached to the tank or the process or the equipment. It basically consists of 3 tanks. So you can have a hot water tank, there's a detergent tank, typically a plastic drum, there's a wash solution tank which prepares and holds the hot cleaning solution. Then there's a process control unit, a pump for circulating the cleaning solution to the fixed equipment. And this is what it looks like. So number 1 here, you've got your detergent solution. So this is your plastic drum, as we mentioned in the previous slide. Number 2 is your controls. So you can see here on the side view where the controls are. You've got your hot cleaning solution in this tank, and then you've got your hot water. In this case, it's 80 degrees C. That would be specific to your cleaning process and what you validated your cleaning for. And then your pump, which pumps the solutions around the tanks. The clean in place process, the cleaning solution is distributed within the vessel, so it has to go across and down and through the discharge pipe. So you need to make sure you're capturing all of the inside of the reactor or tank or whatever you're washing. There are 2 types of CIP systems. You've got your once through running, and in this case, you don't reuse the cleaning solution. It's discharged to the pipe in a holding tank for chemical neutralization, or it's sent directly to a wastewater treatment facility. If you're recirculating it, the used, so it's not saturated, it would be for a secondary wash after you've done your initial rinse. The cleaning solution returns to the CIP unit, and then it's pumped back through the spray device to form a recirculating loop prior to the final rinse with clean solution. So pre-wash is the pre-rinsing. When you do it first, you're going to rinse everything out. The main bulk of your dirt is going to come out in your residues, and that would be operated in a once through mode and wouldn't be recirculated. So again, this is what it looks like. Your fixed equipment must be pre-piped to accommodate the introduction of cleaning solutions through the equipment to contact and clean all the surfaces inside in the equipment. It must have a spray device for distributing the cleaning solution, so all of the interior surfaces will be sprayed and will be in contact with the liquid. All spent cleaning solution discharged to drain, and they're rinsed off then from the clean surfaces. The pressure is something in between 15 to 40 psi's typically. The same surface then is dried using hot air. So for this mechanism to work, you need to have a spray ball. It would be an integral part of this cleaning process, and typically you would find it inside in your reactor. It needs to be in a position where the spray can catch all areas of the vessel. The cleaning solution enters under pressure, and it contacts all the surfaces of the vessel. The design must allow for draining of the solution, so you can't have dead legs in the bottom of your reactor vessel. Again, these would cause pooling, which could lead to microcontamination and also residues of contaminants, cleaning agents, and other contaminants. The solution can go to drain, or in the case of recirculated, it can be recirculated back into the vessel after the initial rinse has been completed. Clean in place cleaning process steps. So number 1, the pre-wash using hot water, that removes your heavily soiled material and that goes straight through the drain. So that's your once through model. Then you introduce your hot cleaning solution. The used cleaning solution is recirculated and pumped back into the fixed equipment, so that's your recirculating mode. The final rinse then using hot water to remove any residue of cleaning solution. Then it's blown down using compressed air to aid the drying process and dried using hot air. The immersion system. So there are 2 types of immersion system, agitated and static. So agitated immersion involves filling a vessel and the corresponding piping with the cleaning solution. That could be some kind of an organic solvent or water or some other type of surfactant. That would be mandated by your validation. And then in agitation, the solution with a mechanical agitator, so that's already in place in the vessel. The vessel then is drained and filled multiple times with rinsed water to remove your soil and your solvent. The rinse solutions are also agitated. The second type then is your static immersion. So this is identical to agitated immersion, but you're minus the agitation. So you're filling your vessel with your cleaning solution, you're draining it and having your rinses. Therefore, the cleaning effect is due to the chemical reaction alone and is not dependent on the agitation of it. Ultrasonic washers, again, generally used for clean out of place. So these can be open or covered. You would probably be familiar with the small ones that you might have seen in the lab. And they can hold water or they can hold a cleaning solution. It's similar to the method that's used to clean jewellery. So mechanical energy is produced through ultrasonic waves and that dislodges any residues that might be there. The cleaning solution helps to wet the residue and to keep it suspended or emulsified. Ultrasonics typically operate at temperatures less than 55 degrees C. High pressure spraying then. High pressure spraying involves using a continuous high spray, directed water or detergent solution to clean parts or the inside of vessels. The pressure could be in the order of 100 psi. Manual cleaning. So manual cleaning is something we're probably all pretty familiar with. So it involves wiping, sink brushing, equipment brushing. It's got very low capital costs, but it has got high variability. So that makes it really difficult to validate. So we prefer to have an automated system where possible. Reflux then is another type of cleaning method that can be used. The solvent is charged into the vessel and it's heated to boiling point. The vapour can now reach any dome of the vessel and any overheads, so your distillation columns, your condenser, areas that are very difficult to reach and difficult to clean otherwise. The solvent selection is really critical and important. This technique can be used in combination with low-tech fill and flush cleaning, so flushing a solvent through the various pieces of equipment and pipework of the process train. There's a piece of reading here for you, What You Should Know About Pharmaceutical Cleaning Validation by Malcolm McLaughlin. So again, worth having a read over there. It is linked in your appendix section of this lesson plan. Over to you. Can you list 4 methods of cleaning? Can you explain the difference between static and agitated immersion? What does a CIP skid do? Thanks very much for your time and attention. We'll see you for the next one.